Hello everyone and welcome to today's video. So today we are looking at route routing loops or however you may say it. So I have this simple topology over here running OSPF. So I have router 3, router 4, router 5 and router 6 OSPF enabled. So let's confirm. So on router 6, show IP protocols or show IP route shows me all the lane routes through OSPF. So show IP interface brief. And as you can see, we have a loopback of 444. Now I'll go to router 1 or router 3. So show IP route shows me that I've learned a route from router 4 on its loopback. So let me ping 4.4.4.4. So we have connectivity between these nodes over here. So now what I'm going to do is that now you see we learn 4.4 from this router, and then I'm going to configure a static route to point to 4.4.4 via this interface. Now what will happen is that we all know that on Cisco routers the default TTL is 225. Once we send a ping and it gets here, you know about administrative distances. So when you have a static route, it's more preferred over dynamic routing protocols due to the administrative distance. So with a TTL of 225, when it gets here, it will be pointed to here because the static route says that we should um, connect to 4.4.4 via this interface. Meanwhile, OSPF is being learned from here onto R3. So once the TTL time of 225 has expired, a message will be sent to R4 or back to R1 that the TTL has expired. Okay, so now back on R5, I'm going to configure a static route. So config T IP route anything. Oh, sorry. IP route 4.4.4.4 255 255 255 255 via the next gateway is I should have checked. Let me check from router 4. Show IP interface brief 3.1 192.168.3.1. Now show IP route shows me that we have a static route to 4.4. Same route has been learned from OSPF, but now because of the administrative distance, the static route has been placed in the routing table. Show IP route OSPF. So now the route has been taken off the routing table because we have a more specific route. Okay. Okay. So now let me go back to R3, show IP route. We still have 4.4.4, and as you can see, it's been learned here through OSPF. So still router 3 thinks that 4.4 can be reached via OSPF, learned from router 6 to through router 4. Okay, so I'm going to start a capture here. Now start another one to here. And I'll filter for ICMP packets just to keep the screen clean. As you can see, we have OSPF packets flying through. So ICMP. Okay, so now back on router 3, I'm going to ping 4.4.4. Okay, so as you can see, it's not going through. Okay, so now let's analyze what we have. So we have between R4 and R3 here. Let's add between R4 and R5 over here. So let me expand the screen. Okay. So this is the first packet, and we should check the TTL. So here the TTL is 254, right? Okay, sorry. So the TTL is 255, not 225. So we have 254, and as you can see, once the static route is pointing to um, this interface, we are in a loop because once the packet comes, it will be forwarded back to R4, and R4 has no um, 4.4.4 in its network. So we have the first packet with a TTL of 254. The second one, it decrements to 253, now to 252, and it's decrementing. As you can see, let me highlight it, or let me add a column, apply as a column, TTL. Good. So now as you can see, the packets will decrement over time. Oh, okay, let me filter it. Okay. So now we have the packets over here. So as you can see, the TTL value is decrementing over time, and the number of hops. So we have 22243. That's echo ping request. So now we have 241, 241, all the way down to scrolling down. It's still decrementing over time because you are in a loop. All the way down, all the way down, all the way down. So let me scroll first, or let me just use the down arrow for you to see the decrement process. So as you can see, the packet is decremented over time, and once the TTL value is down to 0, the packet will be discarded. So it's now down to 50, 53, 40, okay, 30, 20, 17, 14, and then 1, 1. And as you can see, once we get to 1, this interface will send so let's check for this interface 3.1. So 3.1 will be somewhere here. So this is 3.1, and if we do show CDP neighbor, 3.1 is on 500, and then it's pointing to R5. This is R5. So this interface is the interface where R5 has pointed the static route to, and now when the TTL value has exhausted, it will send a message to 1.1. That is the originator of the ICMP ping. This is 1.1. The TTL value has exceeded, and then the packet will be discarded. So as you can see within IPv4, we have IPv4, and the time to leave is 1, and you can go further. So this was a brief, or let me say a breakdown of um, IP routing loop and the TTL value, how it works in our daily networks. So thanks for watching this video, and see you in my next video.